Welcome to your podcast for Lesson 29, Newton's Third Law. After watching the podcast, you should be able to state Newton's third law of motion and describe action and reaction forces. In the beginning of class tomorrow, you should be able to discuss the warm-up with the people in your group. Newton's third law states that whenever one object exerts a force on another object, the second object exerts an equal and opposite force back on the first. So for any action, there is an equal and opposite reaction, okay? And that is Newton's third law. So when you push against the wall is actually pushing back on you with an equal amount of force. Or from our warm-up activity, if the pickup truck strikes an oncoming insect, that insect is also going to strike the pickup truck with an equal amount of force, but just in the opposite direction. Now, that's not usually what we picture is happening because we know what happens to the bug. But actually, the result of what happens to that bug is due to its small mass. Remember from Newton's second law, we learned that acceleration and mass are inversely proportional. So because the mass of the bug is so small, it experiences a very huge deceleration and splats all over the windshield. The truck, however, has a very large mass, and therefore its deceleration caused by the force of the bug is not even noticeable. However, remember that force is the same. Newton's third law states that for every action, there's an equal and opposite reaction. So it is impossible to have an action force without a reaction force. And because of that, we are capable of moving due to reaction forces. For example, if a horse pushes on the ground, we know that the ground is going to put a reaction force back. That's going to be an equal amount of force, but in the opposite direction. So the question I get all the time then is, well, wouldn't those forces cancel out and the net force be zero? But then it leaves us with the question, how can a horse pull a cart? So let's figure out why. What we'll learn on the next slide is that these forces, even though they're equal and opposite, do not cancel out and do not create a net force of zero. Let's take a look at the free body diagram for this particular problem. All right, so we know that when we have a horse pulling a cart, that it's obviously going to move, and it's because of Newton's third law. And so we know that that horse is going to apply a force to the ground, and Newton's third law tells us that for every action, there's an equal yet opposite reaction. And so we know that that ground is going to put an equal and opposite force on the horse. When thinking about these problems, though, we need to keep in mind that we can only count the forces acting on the object, not the ones that are done by the object. So for all of these problems, even though there's an equal and opposite reaction, we're never going to get a net force of zero because those forces are acting on two different objects. So for this particular problem, yes, the horse does act on the ground. Okay, it applies a force to the ground. However, because the mass of the ground is so large compared to the horse, you're not going to notice the acceleration. On the other hand, the force that the ground applies back to the horse is equal and opposite, but the mass of the horse is much less, and therefore you're going to notice the acceleration of the horse, and so that's how a horse can pull a cart. Here's a problem I want you to think about for class. Let's say that your friend and you get into an argument and you say that you can move a football by kicking it off a tee by applying a force with your foot. Your friend says that no, what happens is you get a net force of zero because Newton's third law says that the football is going to put a force that's equal and opposite back on your foot. Who is right, you or your friend, and why?